electricity. Learning about electricity and its importance. Ohm's law. We are now familiar with terms I as current, V as voltage, and R as resistance. Let's look at what Ohm's law tells us. In the first version of the formula, I is equal to V upon R. Ohm's law tells us that the electric current flowing in a circuit is directly proportional to the voltage and inversely proportional to the resistance. The second version of the formula tells us that if either the current or the resistance is increased in the circuit, the voltage will also have to increase. The third version of the formula tells us that an increase in voltage will result in an increase in resistance, but that an increase in current will result in a decrease in resistance. Circuit diagram. It is a schematic diagram in which different components of the circuit are represented by the symbols conveniently used. These are the symbols used for drawing schematic diagram. Components and the symbols. An electric cell. A battery or a combination of cells. Plug key or switch, open. Plug key or switch, closed. A wire joint. Wires crossing without joining. Electric bulb. A resistor of resistance, R. Variable resistance or rheostat. Ammeter, voltmeter. The factors on which the resistance of a conductor depends. This is an arrangement of simple electric circuit. We have 3 wires in which 2 wires are of same material and length but of different thickness, and the third wire, if compared with the second wire, is of the same thickness and length but of a different material. Now let's see what happens. The ammeter reading is 4 ampere for wire connected between A, B. Now, if we double the length of the wire, we observe that the ammeter reading decreases to nearly 1/2. If we use a thicker wire of the same material and of the same length, the ammeter reading is increased. If we use a wire of a different material but of the same length and same area of cross-section, a change in ammeter reading is observed. We have observed that resistance of the conductor depends on its length, on its area of cross-section, and on the nature of its material. Precise measurements have shown that resistance of a uniform metallic conductor is directly proportional to its length and inversely proportional to the area of cross-section. Combining both equations, we get R is proportional to L upon A, or R is equal to rho into L upon A, where rho is a constant of proportionality, is called the electrical resistivity of the material of the conductor. The SI unit of resistivity is ohm meter. It is a characteristic property of the material. That is all in this topic. Enjoy learning!